Okay, so we are the malicious code analysis team, and we're going to be presenting our web tool for detecting malware.
I'm Luke. I'm a rising junior. I'm studying CS. I'm from North Carolina.
I'm Joe. I'm a rising junior as well, and I'm also studying CS.
Hi, I'm Flora. I'm a rising sophomore. I major in statistical science and computer science.
And Celine, unfortunately, I don't think could be here with us today. And then we have our stakeholders, Cisco, and our team leaders, Cara and Anthony. So throughout this presentation, first we're going to talk about our problem, which was preventing malware attacks in the Duke community. Then we're going to talk about our proposed solution and how we came to it. Next, we're going to talk about our final product, demonstrate our website, and also talk about the tools we use to make it. And lastly, we're going to talk about what we learned during this project and what the next steps would be. So first we have our problem, which is preventing malware attacks in the Duke community. So Duke receives a pretty huge volume of emails every single month. And of these, more than half of them are suspicious. Yeah, so a real life example of a suspicious email getting through is in the city of Durham. A phishing attack on the city shut down their entire server network because an employee opened a malicious file in an email, and it ended up spreading out through their whole network. So in terms of creating a malware analysis tool to prevent suspicious emails or suspicious files from being opened, we found a few areas we could expand on with the current malware analysis tools. The first being that a lot of them were very complicated to use, so we wanted to make something as simple to use as possible. Another issue was that they are very resource intensive a lot of the time. They can also be very technical and require a lot of kind of computer knowledge to use, so we wanted it to be something that is not very hard to set up or understand. And lastly, they can be non-universal, so they won't work on every type of device. Like there could be some that are specifically for Macs or specifically for PCs. So our challenges as we started working through the project was, first, we had a little bit of difficulty framing what we wanted to do for the project. Initially, we were going to create a malware sandbox that would do dynamic malware analysis, but this seemed to be a little bit out of the scope of 10 leaks. So we instead settled on doing a static malware analysis tool. It was also a challenge to collaborate remotely, especially because we have 2 team members who are international and 2 team members who are based in the US. So it's kind of difficult to collaborate across time zones. Another thing is we had to learn how to detect malware. So we had to research the different types of malware detection and also find tools we could use to detect malware. And lastly, we had to learn a lot about web design. So we had to learn HTML, CSS, and then we also had to learn the Django library for Python, which we used as the framework for our website. And this is just a little image of the different time zones we're in. So we have people in the US, we have one in Kenya, and we have one in China. So we're all across the world here. Okay, and then next, Flora is going to talk about our solution.
So our solution is to create a web application that can prevent malware attacks in the Duke community. Throughout the program, we have continued to refine our product from feedback and research. We significantly changed the scope of this project from a sandbox denotator to a static analysis web application after we got feedback from Cisco in our own observations on the current landscape of malware detection. Then in our wireframing process, we refine the details and features we want to include by presenting to other teams, Joel, and other parties. The 2 screenshots here show how our wireframe evolved with our project. For example, initially, we classified the potential files from users into emails, URLs, and Office documents. Receiving feedback from our project lead, we then decided to reduce the file categories into URLs and attachment. Our final product continued to evolve from there. The final project only has one button, that is to upload any file that a user wants.
You there, Flora?
It looks like she might be frozen.
Yeah, she's.
Okay. Well, in the meantime, I can take over for Flora. So our web application aims to solve the problems of existing technologies that Joe covered. We really cared about the usability and functionality of the web app. And so you can see here some of the principles we designed with in mind. So we wanted to build a simple and intuitive tool that would be really easy for users to learn and handle. And also we hope to test for common analysis that a user might receive and then be able to connect them to other tools for how to deal with it or prevent malware attacks in the future. And so now I'll share more about the toolkit that we used and demo the web app itself. All right, so this was really a full stack project. And these are some of the main tools we used. Django is a Python web framework, which we chose for its flexibility and our own familiarity with the language. Then for the malware detection portion of the backend, we used Yara, which is an open source binary matching library, and also the API from VirusTotal, which is software that matches malware with previously detected malware samples. And then we designed the front end with HTML and CSS, of course, using Adobe Dreamweaver. So now I'll demo the web app, and you guys can get a little bit more of a complete picture of what we've been doing. All right. So again, this is a website that performs static analysis on any file uploaded by the user. This is the home screen. The landing page, it provides some information and some instruction for the site users. So I'll start by uploading an Office doc like suggested. And I'll upload this one that I know is clean of any malware. So after submission, the static analysis will run, as you can see, and then we'll be rerouted to this verdict screen. So you can see loud and clear that this file was totally safe, but we can click here, click to upload another file, and that'll take us home, and we can upload another file. This time, I'll upload one that is not so clean. This is a file of malware that we got offline, and we'll just use it to demonstrate what that would be like. So once we run this dangerous file, again, it's going to process, and then we can see very clearly that the file isn't safe. So the website includes some guidance here to the user about sort of what to do if they've opened it. Of course, they should contact OIT. We also link here from this hyperlink to OIT's own security resources page so that they can find more tools. We also have this alert OIT button. And if a user clicks this, it'll automatically send an email to OIT, and they'll be notified, and they can take a second look at the file or contact the user for more support. This last button, View Technical Details, provides more information for technical users. So you can see here are the behind the scenes reasons the file was flagged by the Yara system. For this one, it's the VBA macros. And then this button directs towards the VirusTotal provider and gives more information through that system. But we'll just return home now. This system will also return an inconclusive verdict if the analysis was unclear. But I hope you've gotten a good sense of the power of the static analysis tool and the simplicity and ease of the website we've designed. So with that, I'll pass it off to Joe to talk more about our reflections on the summer.
Thanks, Luke. Okay, so you can go next. So first, I'll talk a little bit about our growth throughout our Code Plus experience. The first thing was that we were exposed to a lot of new software. None of us had previously worked with malware analysis, so we learned a lot about different tools you can use for that, and also a little bit of insight into how those tools work and the different types of malware analysis. Another thing was we gained a lot of team experience. So we got a lot of experience organizing and staying in constant communication with our team, especially trying to overcome the barriers of working remotely. And lastly, we got some practical work experience. So we gained some time just presenting to people and like sharing our ideas in a work setting. Excuse me. And yeah, also just putting in like an 8-hour workday every day and making sure to stay on top of things. Okay, next. So these would be the future ideas we would have if this project was continued. The first thing would be to add additional YAR rules. We added a good amount of YAR rules in terms of analyzing Word documents and EMLs and also PDFs, but the other thing that could be added is there could be YAR rules added for executable files or really any type of file. It wouldn't be too difficult to do to add that. And another thing is just adding additional rules for the ones we already have rules for, like Word documents and stuff. It would be interesting to research more and try to add some more. And that would be as simple as dragging and dropping folders or dragging and dropping new YAR rules into the folders that we have. Another thing that would be interesting to experiment in the future is maybe some form of machine learning malware detection. This is something that's kind of been on the rise lately and people have been experimenting with. And our current setup is that we use signature detection for our malware analysis, but machine learning would be kind of a distinct and also sometimes more effective way of detecting malware and things. And lastly, some form of dynamic analysis would be really good for this tool because sometimes dynamic analysis can pick up things that you can't detect with static analysis. Dynamic analysis being just when you run the file in some type of malware sandbox and then see what the file does once it's run. And that concludes our presentation. Thank you guys for checking it out. And if anyone has any questions, feel free to ask.
Thank you all. That was great. Thank you. Sorry for the technical difficulties you ran into with the internet connection, but as we said, this is virtual and we're going to run to at least one of them a day or one of them a presentation. So way to go. Way to overcome that. So I have a question. So you envision the who would be the primary audience for this?
It's really just for people in the Duke community, like anyone who really anyone at Duke who wants to test a file out could try it out. Yeah, it's pretty open. We tried to make it as widely usable as possible.
And so would it know who I am? Do I log in? Would you envision me logging in somewhere?
No, we didn't add any type of login because we didn't see it as being super necessary in terms of like we weren't really going to do anything with that login information besides maybe just verifying someone was in the Duke community.
Mm-hmm.
But yeah, we decided to focus on other things instead of setting up the Shibboleth interface.
Okay. And what happens when someone when it's an inconclusive? When you're not sure?
With an inconclusive verdict, we hope that the user uses like the alert OIT button, and so they can get a second opinion from a professional, or hopefully they just kind of play it safe and don't interact with the file too much. But we wanted to provide a little bit more nuance in the verdict. So, you know, those tool's never going to be 100% accurate. So the inconclusive verdict helps account for some of that.
This is great. I like the idea of having a sandbox people can go to open up files and make sure that they're not going to destroy their system. From the security office, we have a few folks on the chat or on the team or in the space. Do we have?
It looks like we got another question in chat from
okay,
Harry.
Great.
Yeah. Do you expose any APIs for other services to consume so they can check for malicious content? Harry asks.
Yeah, we don't have any API that we exposed for this for people to use, but one thing that could be useful is we actually use the VirusTotal API in this, which was pretty helpful. So that could be, if you're trying to create your own tools or something, that's a pretty intuitive API to use.
So Anthony or Philip, what are your thoughts on using this from the security office's perspective?
From my perspective, it's definitely something that I want to see if we can take over and potentially push out once as they talked about, we'd like to add some more Yara rules. There's some more stuff we want to throw in, but they've gotten us a long way there. And I think this could be a really cool tool for us to be able to push out to the community.
I like the idea of having the executable Yara rule in there as well. I think that would be awesome.
Yeah, I just wanted to add from the security team, from an operations perspective, we've been performing some of these tests in the past. But what's really great about this is we're expanding this functionality to hopefully introduce it to students, faculty, staff, folks at Duke that wouldn't be aware of, some of those security tools that we're used to using outside of Duke. This gives us a better place for, as they've mentioned, you get a suspicious email, you're not sure what the attachment is. We don't want you just opening it and testing it or playing around with it. So this is a really cool tool. They've done a great job.
Yeah, there's a big kind of variety of people who get suspicious emails, from the people who will forward the security office anything that they find that looks even a little bit weird, which is great. But there's also people who are, there's people who are kind of have the mindset of, I don't want to bother those guys. They're probably busy, and maybe they'd be more open to using a tool like this that could give them at least an idea what's going on. And there's also the people who curiosity will get the best of them, and if they don't have a safe way to play with something, they're going to just open it and see what it does. So if we can give them a safer way to do that at the same time, I think this tool really kind of expands the options for people and gives us a better audience of people who can test things safely and then give us an alert if something suspicious happens.
Thank you. The interface was very clean and easy to read and understand, straightforward. So I think it's definitely something that vast majority of the users can take advantage of.
We got one more question in chat. Does the project have a GitHub? So if there's a team member who's on who might be able to provide that.
Yeah, we do have a GitHub. We haven't made it public yet, though. I guess we could just do that, and then I could share it.
So is this something that you think could be used at other organizations or institutions?
As far as using it at other institutions, I don't know. I don't think it's something that could really go commercial, just because of we're using like tools like the VirusTotal API, where if we tried to kind of market it commercially, it would be like a breach of the use of that service. So that would probably have to be removed if we wanted to like sell it to other schools or something, or let them use it. I don't know.
Well, this was awesome. Thank you very much.
I have one question I have. So like, what was the most challenging part working on this project for you guys?
I think we would probably each have different answers for that. For me, it was the front end. I designed a lot of the HTML and CSS, which I'd never done before, and I was just kind of, you know, haphazardly learning it. But luckily, the program included some good training modules, which really helped me overcome that. And yeah, I think we ended up with something we can be proud of.
Cool. Yeah.
Well, thank you very much. That was excellent.
Sure. All right. Thanks, y'all.